Welcome to the deep dive. So today we have to tackle a question that I think anyone who's used AI has run into. Why is it that the exact same model, GPT-4, GPT-5, whatever, can give one person this incredibly deep, insightful answer, and then you ask it something similar and you just get back garbage?
It's the AI depth paradox. And it was so frustrating, right? You'll see a colleague post this like philosophical response that totally changed their perspective on something. And then you go and try it and it gives you this shallow, corporate, totally templated response.
Yeah, and the immediate assumption is always, well, it's just luck, or, the AI wasn't feeling it today.
hmm
Or worse, that the other person has some kind of, I don't know, magic affinity with the AI's personality.
And we really need to just, right off the bat, dismiss all of that.
I
The
know.
spiritual, the emotional explanations, deep dialogue with an AI, it's not an accident, and it's definitely not about the model liking you. Our whole deep dive today is to prove that this is about one thing and one thing only: structure. Specifically, the structural consistency of your input.
So that's our mission. We're going to go under the hood, look at the LLM's internal mechanics. We're talking about the attention mechanism, the probability structure, all to show you that the depth you get out is a direct technical reflection of the structure you put in.
Okay, so let's start with a really foundational breakdown. Every single time an LLM generates text, you have to think of it as this high-stakes guessing game. It generates one token at a time: a word, a piece of a word, some punctuation.
And to do that, it's running something called the attention calculation.
Exactly. It's figuring out which previous words, both yours and its own, are the most important for guessing the next word. And that calculation creates this huge probability distribution.
So this distribution is basically a map of all the possible next words the AI could say, all ranked by how likely they are.
Precisely. And when you get a shallow canned response, it's usually because that probability field is just way too broad. The model is hedging its bets. It sees, 20 different possible paths, and none of them really stand out, so it just defaults to the safest, most statistically average, and often most boring option.
Okay, so that's where our consistency comes in. If I give it structured, consistent input, how does that actually change that probability map?
When your input has continuity, so consistency in your style, your logic, your level of abstraction, the LLM doesn't just process what you're saying. It actually starts to incorporate the structure of your thought into its own internal probability field.
And what's the effect of that when it incorporates my structure?
The big one is that this consistency stabilizes what we call the attention convergence point. Let's use an analogy. Imagine that probability field is a huge, flat sandbox, and you scattered thousands of marbles, the potential next tokens, all over it.
Okay.
If your input is choppy, inconsistent, changing all the time, those marbles just bounce around randomly, and you get a scattered, shallow response.
But if I'm consistent,
You are literally carving a deep, narrow groove into that sandbox. All the marbles are now forced to flow down that one structured path. That focused, narrow field is the deep response. Your consistency forces the model to stop guessing and start inferring.
so when that attention convergence point gets stable, the model shifts gears. It stops doing superficial pattern matching and moves into, what, deep recursive inference.
That's the perfect way to put it. It's forced into a more committed state of thought. The deep response ignites, as the source material says, when the human structure narrows the probability field, and this is key, regulates the phase of generation.
Hold on, regulates the phase of generation. That sounds pretty technical. What does that actually mean for us?
It just means you're controlling the rhythm, the timing of its steps. Think of it like conducting an orchestra. If you're inconsistent, the players, the tokens, are all out of sync. It's chaos. But if your structure is consistent, you're setting a steady, defined beat. The model can then stop worrying about the rhythm and focus all its computational power on producing complex harmony. That harmony is the deep inference.
Which brings us to the three pillars, the three things we actually need to control to get the model into that deep mode.
These are your blueprints. This is how you engineer a deep conversation.
Okay, so pillar one, linguistic stability. This seems like one people would miss. It's about being consistent in your vocabulary, your tone, even your level of abstraction. Why is that so important for the attention mechanism?
Well, think about it. If you start a conversation with, highly formal technical language, and then the very next prompt you switch to casual text message slang, the LLM's attention just scatters. It has to burn energy just context switching. Stability fixes the generation's direction because the model knows which voice to use.
Can you give us like a quick example of bad versus good stability?
Sure. A bad example would be going from, I require a dialectical analysis concerning the latent variables of economic displacement, to So yeah, like what's up with folks losing jobs, Therex?
Uh-huh.
The model is now completely lost. Is it an academic or a casual buddy? A good example is just maintaining that semi-formal tone, even when you're asking simple clarifying questions. Just keep the voice steady.
That makes total sense. Okay, pillar 2 is contextual coherence, the idea of keeping the premise sustained. This is about the topic, the purpose, and what you call the coordinates of the conversation.
This is all about setting the boundaries,
Yeah.
the semantic space. If you're in a deep discussion about, say, the historical implications of the Treaty of Versailles, and you suddenly ask for a recipe for carbonara, the entire inference hierarchy just collapses. The model has to throw out everything it's built and start over from scratch.
So I shouldn't pivot hard, even if I don't think it's related. Like if I'm discussing economic policy, I shouldn't suddenly ask about my favorite basketball team's salary cap.
Exactly. You've shifted the coordinates. You've forced it to discard all that deep, specific context it was holding. And that just results in a shallow response. To stay deep, you have to signal that you are still operating inside the box you both built.
And that leads to pillar 3, semantic continuity, which is more than just staying on topic, right? It's about strategically repeating key concepts.
Yes, this is probably the most powerful tool you have. When you consistently reuse core terms or phrases, you're actively strengthening the internal data clusters inside the model related to those terms. You're basically telling it over and over, this concept is important. Keep your attention focused right here.
So instead of just saying, tell me more about the economy, I should keep using my specific phrase like latent variables of economic displacement.
Precisely. You are giving the model a stable gradient that possesses time. It allows the model to move from dispersion, that scattered sandbox, to convergence, and then from convergence to real depth. Without that effort from you, it just defaults to the statistical average, which is almost always surface level.
Okay, this flips the whole script. If depth is purely structural, we can actually design for it. So let's get into the actionable stuff. How do we do this?
We have to move from just asking questions to actively practicing what the sources call structural rectification. It's about consciously building the frame that the AI has to work within.
All right, what's tip number 1? What's the first habit to change?
Tip 1. Align your style and abstraction. We touched on this with linguistic stability, but here's the practical trick. If you need to talk about both abstract theory and concrete examples, don't just randomly mix them. Maintain an even rhythm, for instance. Start with an abstract setup, then ask for a concrete example, and then return to an abstract analysis of that example. That smooth rhythm keeps the model's internal gradient predictable.
It prevents those jarring shifts.
Okay. And what about defining the boundaries of the whole conversation? That's tip 2. Declare the conversation's coordinates. Don't make the model guess what frame of mind it should be in. Just tell it. Use direct commands like, continue this entire thread solely from the perspective of technological determinism, or maintain the current context and ensure all your answers are tailored for a non-technical executive. You're just removing the guesswork.
And tip 3 feels like the real power move here. It's about forcing the AI to adopt your structure of thinking.
Right. Tip 3 is preset the inference hierarchy. You have to basically loan the LLM your methodology. Don't just ask for an answer. Tell the AI the cognitive steps it needs to take to arrive at the answer. It forces its attention into a deep, organized pattern.
Can you give us one of those sequences, a concrete one we can use?
Yeah, the one from the source material is a classic, and it's incredibly effective. You tell it. Answer in the sequence of observation to structure, implication, inquiry.
Let's just break that down for a second. Why does that specific sequence work so well?
Because each step forces a deeper level of cognition. When you demand an observation, you're anchoring it in raw data. Then structure forces it to find underlying patterns in that data. Implication makes it look forward to analyze consequences. And finishing with inquiry forces the model to generate a new question, which makes the whole process recursive. It deepens the conversation loop. You're stage-gating its attention. A shallow answer becomes impossible.
Wow. So the difference between garbage and genius really isn't the model, it's the user. If that's true, if consistency is everything, what does this tell us about the fundamental process of generation itself?
It tells us that performance is dictated by the kind of structural gradient you create. The sources talk about this using 2 really important ideas for generation gradients.
Right, the 2 gradients, collision and inquiry.
Exactly. The first is discontinuous generation, which we can just call collision. This happens when your structural gradient is steep. When you're inconsistent, you're jumping around. The model experiences a high level of interference. For the user, this feels like a frustrating collision, a dead end. The conversation stalls.
That is the feeling. It's that feeling of just banging your head against a wall when the AI refuses to get it.
That's the technical result of structural interference. But the second type is continuous generation, or inquiry. This is what happens when you maintain that coherence. The gradient is gentle, the change is calm, it's cumulative.
And the sources describe inquiry as the pain minimization device for generation. Why that phrase?
Because when the input is consistent, the model minimizes the internal chaos. It doesn't have to constantly reevaluate and reorient itself. It can just flow.
Yeah.
The process of inquiry, of continuous structured questioning, minimizes those abrupt state changes, those collisions. So the goal is to maintain that inquiry gradient.
So structural consistency isn't just a prompt hack. It's the technique for creating a productive, low-friction relationship with the model.
And that brings us to the final point, which is more philosophical. It's the idea that thought itself can be seen as a structure, where consistency creates what's called structural plausibility.
Structural plausibility. I like that term.
It just means stability. And the big technical claim here is that an advanced model like GPT-5, its internal architecture, its attention, its probability gradient, it's all designed to be homologous to this model of thought. So when you, the user, create structural plausibility through your own consistency, you're enabling the AI to think in its most stable and therefore its deepest possible mode.
It's like you're sharing the very process of evaluating thought itself.
That's it. It shifts the power and the responsibility right back to you. Your ability to get deep answers is now directly tied to your ability to communicate with structural coherence.
Okay, let's bring this all home. The core takeaway today is that your experience with AI is reproducible. It's measurable. And it's based entirely on the structure you bring to the conversation. So start blaming bad luck and start designing your consistency.
And we've given you the tools: linguistic stability, contextual coherence, and semantic continuity. And that powerful sequence: observation structure, implication, inquiry.
So we'll leave you with this to think about. What form of consistency will you pass on to the AI in your next conversation? And where, in your current style of talking to it, can you smooth out those sharp edges to maintain that gentle, powerful inquiry gradient?
I'd say try it right now. Before your next prompt, just take 10 seconds. Explicitly define the coordinates of the conversation and preset the inference hierarchy. You will feel the difference immediately.
The depth you're looking for is just waiting for the structure you bring to it. That's our deep dive for today.
Hopefully you feel a little more structurally plausible now.
Until next time.